Now, it's true that an expertise constraint can be solved by adding more experts, building those extra lanes, if you will. However, there are cases where an expertise or a specialization constraint can be solved through other means like automation, self service, or a process or policy change. Sometimes increasing capacity might just slow things down further with the burden of onboarding new members because you have to train them and everything. So it's important to be aware of the different available options and when to apply them.
That's right, Dominica. Now let's take a slightly different traffic flow example. We're all familiar with toll booths on a highway. As we approach the toll booths, traffic starts to slow down because people have to interact with the toll booth operator. As a result, cars can begin to back up as they wait their turn to go through the toll booths. Now imagine there are 10 toll booth lanes, but only two operators are currently working. So cars are forced to merge from 10 lanes into 2 lanes, making the wait time even longer. That's a clear case of resource scarcity. But there are two ways you can solve it. You can either add more toll booth operators or you can automate the toll booth. Most toll booths today have a fast pass system that allows people to just drive through the lane as it scans the tag mounting on the inside of the vehicle's windshield. You still might be forced to slow down, but much less so, and the throughput is much higher, preventing a backup. You've managed to automate something that once required a human interaction. This way, you're not dependent on having a resource or expert available. You also don't need to slow down quite as much, which mitigates the long wait times.
Nice. Let's apply that to the world of software now. In software, it's often the case that a manual process or mandatory human interaction constrains flow. For example, a common issue for value streams is getting new code tested in pre-production environments because those environments are scarce and not self-service. As a result, there's new product capabilities or fixes to defects that pile up in the ready for test state. Just like in the previous example with the bridge, the constraint is in the subsequent active state of in test, where code changes are actively validated in a pre-production environment. But the pileup is really in ready for test, where the code changes sit and wait until a test environment can be provisioned for them. How will you see this in Viz? In this example, your bottleneck analysis will show high artifact counts and state durations in the preceding ready for test wait state, which is a symptom of the constrained in test active state that follows. How do you solve it? Let's look at the highway. Introducing fast pass lanes automates the human interaction with a toll booth operator, reducing wait times, and it improves your throughput. So if you automate test environment provisioning and allocation, that will help improve flow for the value stream because it allows the teams to execute routine testing in pre-production environments as much as possible without relying on a central team to provision the environments because the central team's priorities may change. Your team's priority might not be their highest priority.
In summary, when performing flow or bottleneck analysis, remember that a resource or expertise scarcity or lack of automation is in an active state, but is first spotted in the preceding wait state where work piles up and ages.
Nice, Carmen.